Welcome to the Code with Jason meetup. Today we're going to continue working on our object-oriented programming lessons, or whatever you want to call them. I'm going to share my screen here. I'll catch you guys up on what was done last time. So for anybody who's tuning in for the first time, I've been working on some Ruby object-oriented programming lessons using this example of an expression parser. So the idea, maybe I can pull it up in my book here that's in progress. The idea is you can take an expression like 2x plus 5, for example, or 2x plus 5, and this program parses it into a tree. So that's the idea, and it is not that easy. And here's a more complicated tree. But we have a little bit of it working so far. So we can parse expressions like 2 times x, or just 2x, or 2y, x divided by 3, x plus 5. And I think the latest one we're working on that I started in the last session, which you guys weren't here for, at least most of you weren't here for. The one thing we don't have going yet is an expression like 2x plus 5. So the reason this is different is because it has nesting. These other expressions, like x plus 5 or x divided by 3 or whatever, they're not nested, but this expression has a sub-expression. And I had to change the design quite a bit when I added this nesting case, because before I was just using scalar values, integers and strings. And I was saying, like, when the expression is 2 times x, then the root is the time symbol, left child is 2, right child is x. But if you have nesting, then you're going to have like the left child is the expression 2x. And that's like a different kind of thing. So here's how I addressed that. I ended up creating this token class. So why token? Because I had to have a term that encompasses all the parts of an expression. So inside the expression 2x plus 5, 2x is an expression, 5 is an expression. So it's two expressions inside of a bigger expression. But plus is not an expression. That's obviously just an operator. So what's a term that applies to an expression and an operator? Well, I asked ChatGPT, and it gave me the idea of token. So here's a token, here's a token, here's a token. That's why I created this abstraction called token. And it just has a value, and it can be cleaned in case there's any trailing or leading spaces, or if it's like a string that really is supposed to be an integer, it addresses that. So now an expression is made up of tokens, meaning that our expression class where the parsing happens, it initializes tokens. So here, for example, is a token. We created a token that is the multiplication operator. All right. So what I did was I paused and I said, okay, I can't do the nesting until I refactor it all to use tokens. So I paused, I backed up, and I said, let's forget about the nesting for a moment. And then I refactored everything to use tokens. And now I'm reintroducing the nesting, because I didn't want to mix the jobs of adding the nesting and doing the refactoring to tokens. I wanted to have those as two separate atomic activities. Okay, so now, how do we get this test to pass? It's on line 101 is the test we're looking at. Has a left child with root of times. So we're asserting that when we parse this expression, the left child is times because it's a sub-expression of 2x. Again, if we look at this diagram, the right child is just 5, but the left child is times, which itself has 2 children. So how do we do this? The answer is I don't know, so let's figure it out. Right now we get undefined method value for nil class. So expression.leftchild.root is nil. All right. Well, where does expression.leftchild.root come from? Oops. Let's look at this initialize method. So in the parse method, we just initialize a new expression. And so here in the initializer, we go through these operators. What are the operators? Those are here. So far, plus, division, and times. And we go through each of those and we say, if that operator appears in the expression, then assign the root to that operator. And then split on the operator and assign the left and right child accordingly. So for an expression like x plus 5, it would go through and it would say, okay, it does include the plus sign, so we're going to assign the root to plus, and then split it on plus. Left becomes x, right becomes 5, because it's x plus 5. And then we just return. All right, and then if it doesn't find any of these operators, then it checks to see if it's a constant. And if it's a constant, then it's going to have no children, like just the number 5, for example. And then if none of that stuff was the case, then we assume that it's multiplication, which is not a way of approaching it that is going to survive the test of time probably, but it at least works the way it is now, and we'll refactor it when we need to. So I think what's missing is recursion. We aren't parsing the expressions recursively. For 2x plus 5, we need to not just say split this and give us this 2x token and this 5 token. We need to say split this, parse 2x, and parse 5. And so I think maybe we have a mismatch here. This business here happens in the initializer for expression. But again, not everything in here. Wait. I was going to say not everything here is an expression, but maybe that's not true. 2x is an expression. 5 is an expression. So we parse this expression and this expression. Okay. All right. What is split on? I actually find it slightly confusing that it says split on character. It's always going to be an operator, so we might as well do that. Okay. So we split it into parts. And here we're doing token.new. I think we want to actually do expression.new. And this is also a little confusing. I'm doing children and children.map. I think it might be clearer if I say like child expression values. And I'll split this onto 2 lines so we can see everything. And actually, I think I'll just inline this. And I'll take it one step further even and inline this. Oh, whoops. I made a mistake here. There. Okay. So we split on the operator, and for each of these child expression values, we make a new expression. Surely this will not work, but I don't know exactly in what manner it's going to fail. So let's see what happens. Infinite loop, because we don't have a base case. Okay. I'm a little bit surprised by that because expression.new only gets called from split on, which doesn't get called from everything. Let's see what's going on. Let's put a binding.pry here. I don't have pry. Okay. That's a fixable problem. I don't think I even have a gem file. Um, okay. Okay, let's see if that works. Okay. And now it's unhappy about RSpec. So let's fix that. And that is taking a long time for whatever reason. I'm going to kill it and do it again to see if that makes it go faster. And it did for whatever reason. Okay. Now we get the pry. Okay, so what is value? Value is 2x. So we've gotten here, and so it is going to call split on here. Um, which is appropriate. It should. Okay, so now what's the value? The value is just x, but it's not going to stop. It's going to go here and it's going to call split on. So we need a way of addressing this base case here. Here's an idea. We can say return if value dot length equals 1. Because then if it's just x, it won't get past there. Oh, and that just passes. Okay, wonderful. I wasn't expecting it to be quite that easy. Okay, both these pass. What about everything? No, there's some failures, which is not surprising to me. All right. And when I have like just a wall of failures like this, I like to focus on one and run it by itself. Okay, 2 times x has a left child of 2, undefined method value. All right, line 28. Okay. The expression doesn't have a left child. All right, so let's see what's going on here. 2 times x. It should get split on times, and then, oh, I see. It's because it's returning not a token, but an expression. And an expression doesn't have a value that's publicly accessible. Okay, so what if I just add value to this? Okay. This doesn't feel right. Hmm. I think maybe I want to do this. If value.length equals 1, all right, so I'm going to undo what I just did, adding the value here. I'm going to say if value.length is 1, then what? Um, okay. The value of this right now is 2. Okay, so this is an expression with a value of 2. How do we want to do this? Like, do we want these leaf nodes 3x, 2, 5x? Do we want these leaf nodes to be expressions or tokens? Or is every expression also a token? Or is every token also an expression? No, not every token is an expression. Plus, times, those aren't expressions. But I think you could say, if you wanted to, that every expression. No, not every expression is a token, but some expressions are tokens. Yeah. But tokens have values and expressions also have values. Yeah, okay. So I actually feel like I did the right thing the first time. Let's add back value here. Okay. But we need to clean up the value. How do we want to clean up the value? Um, we can do this if value.length equals 1. This is going to be duplicative, but bear with me a second. Hmm. This is just too duplicative. This feels dumb. Well, let's do it anyway. I'm just going to copy this. I'm going to copy both these. What the heck? Okay, if value.length is 1, clean, and return. Okay, and that should take care of that too. No, it doesn't. Okay. And why doesn't it? Okay, value. Value's x. We're not expecting that to turn into an integer. Oh, okay. It doesn't always get here. Interesting. So in this scenario, it's 2 times x. It gets split on times, and it's just returning this expression. Okay. Okay, and what happens in that scenario when the expression is just 2? Okay, we have 2 times x. Now we have 2. Okay, what's going to happen now? The value is not going to include any operator. Oh, it's going to be a constant. But then it's supposed to be a token. And it's supposed to get cleaned. Oh, we're assigning that to the root, but we're not doing anything with the value. Okay, here's an idea. Not going to copy this stuff. I'm going to say value equals root. Yes. Sorry, value equals root dot value. Let's get rid of this binding.pry. Okay, that passes because when we say is the value a constant? If so, then clean it. So that's why the string 2 gets changed to an integer 2. Let's see what fails now. Looks like we have fewer failures. Yeah, it has a right child of x. That's failing because it has no root. Yeah. I'm actually not sure I need clean yet. So let's not add it. Okay, that passes. Okay, everything except one passes now. Okay, so for addition, it's supposed to have a left child of x, but instead it has times. I'm guessing it's getting to here. Looks like it. So value is x space. Okay, if we had stripped it, then it would hit this if value dot length equals one thing. We could do this. Okay, that's no good. We can just do value dot strip dot length. Yeah. Okay, expected and got x, expected x and got x space. So now what if we do clean there? Okay, now it passes. Huh, and now we have more failures. Okay. Infinite loop. That's funny. We're back to here where we started. Now this is not working. Okay. So if it's plus, we get infinite loop. 2x plus 5 gives us an infinite loop. And why? Let's find out. Okay, so here we have 2x. Oh, and then we just have space. Okay. Space again. All right, I think this space is like unhealthy. Let's, instead of doing value.strip here, let's just start off with a stripped value. What happens then? Oh, wow. Okay, everything passes. Okay. That was a lot. I'm going to commit this. Oh, I added white space somehow. Okay, I'll take care of that. I added white space and I added this unnecessary value reader. Okay. And that is why I always review my changes before committing, because I often find things that I did not intend to commit. Okay. Where's this white space? I don't know. Okay, the white space is right after that operators loop. Okay. Oh, and I don't want to commit that require pry either. Okay, I took care of that. I think there was at least one more thing. Oh, okay, I did not take care of that. Oh, it's right before the value.length. Okay. Okay. Oh yeah, in token, I don't know if I need that root reader. Oops. Okay, I do not. Okay, now that was good. Add nesting support. Okay, but the problem, is that I think my domain model is nuts. I think the way this code works is just kind of crazy. Um, let's see. Sorry, I'm trying to decide if I want to turn the AC down or take my shirt off. Just my outer shirt. Don't get too excited. Um, okay. So what am I not satisfied with in this code? Before I answer my own question there, I've been talking a lot with a lot of without a lot of audience involvement. Francisco, do you have any feeling as to what about this code I may be unhappy with?
I think maybe did you commit? How about commit and then refactor the next commit? But let's see. I don't have anything immediate off the top of my head.
I feel
There's some strips kind of like sprinkled in around there. I don't know if you need that strip right there, that value. Could you put it initialize or
well, I feel like it's something more fundamental.
um
Like,
the whole token versus expression, right? Of one is
yeah,
one and not the other one is not the the other direction.
like maybe I feel fine about that, but I'm not sure if I do or not. It's like token and expression are kind of like mirroring each other in a little bit of a weird way, I feel like. They both have value, but maybe token is like overly specific. Maybe it should just be like something like that. I don't like the name expression value, but I don't want to just call it value. But like, this could be like mathematical value, something like that. Except a value doesn't have a value. Could say it has content. Um, hmm.
It's like there's a slight smell, but can't
Yeah.
pin.
Let's see. Is an expression a mathematical value? I guess we could say yes. It because like right now, token does is it like does some cleanup stuff. Like it can
Casting.
change. What's that?
It's like casting almost.
Yeah.
It's for the primitive.
Yeah, I feel like this is a type, or maybe it's actually multiple types. Hmm.
Do you have any other test cases you're thinking of adding?
Oh yeah.
Yeah.
Um, well, okay, let's take a look at this. I think this thing that we're currently calling token, well, it might be something like three or something like X or something like times. We could also maybe think of it as a node. Hmm. But it's like expression kind of duplicates token a little bit. They're polymorphic for sure, because an expression has a value and a token has a value. And like sometimes in here when we're doing dot value, sometimes what's being returned in dot value is a token, and sometimes it's an expression.
Okay.
And maybe that's not bad. Okay. Okay. Here, the token's going to be an operator. Here, the token's going to be a constant. Maybe actually here, I should be saying expression.new. I'm just curious if that changes anything. Sure does.
Oh yeah.
Okay, I get infinite loops. Um, okay, but like if it's a constant is an expression. A constant is an expression, so it makes sense to return um oh, I think maybe the very first okay, I'm gonna do something here. Okay, so all the tests are passing right now. I feel like it is a little bit more logical, maybe, just to up front say if it's a constant, then like just don't do anything. It's like the simplest possible thing, you know, the value being a constant.
That still passes? Okay.
Yeah, and then like if it's just a length of one, this feels a little weird. Why do we do this? Oh, I guess that's like if it's the case that it's just X or something like that. But this is actually making it a little bit easier for me to think about it. Just having like the let's get the simplest things out of the way first. Is it a constant? Okay, return it. Is it just a length of one? Okay, return it. Otherwise go through the operators.
That's better.
Yeah, I'm gonna commit that.
And the fallback is always multiplication.
Yeah, which I'm not totally comfortable with because that's like logically that's just kind of weird. It's like, okay, if it's not anything else, it is
Yeah.
multiplication. It's like
Yeah.
why?
Yeah. Yeah. Do you need
Okay.
those lines? Do the test pass if you remove 33, 34?
I don't think so.
Oh no.
Yeah, because you know, if it is like 2x, then it doesn't get caught by any of these other ones.
Okay.
Um, yeah. Although something I thought about that might be interesting is like you could do something like this. So one of the operators is just, oh, but then, you know, it's like, does the string contain an empty string? That doesn't make sense. So we can't do that.
Mm.
Okay, but actually, maybe this isn't as weird as I thought because it's like, is it a constant? Do that. Is it just a length of one? Do that. Otherwise, go through the operators. And if we still haven't found anything, it must just be a term that's like 2x or something like that. And so it means multiplication.
Yeah. Like if someone were to read that code, they'd be like, why is line 33 that? You know? But the
That
tests
is
prove,
true.
I guess, that
Yeah.
need it.
Well, I'm hoping that as the code fills out, a
It'll
more
be,
logical way of presenting that will become evident.
yeah.
Okay, so back to like tokens versus expressions and stuff like that. Um, it feels kind of weird to ask in this way if it's like we want to know if this value is a constant. Feels kind of weird to make it a token first because it might not really be a token. It could be something like, well, I guess it'll always be a token. I don't know, is 2x a token? No, I don't think it is. I think a token is like a single value.
It's a what do you call it? It's a primitive, right? It could be a string or an integer, just without any value.
I don't know if it's necessarily a primitive. It's just conceptually a um a token is like a single thing. Like
You're done. You're done. There's nothing else left to calculate. It's a final value. It's a leaf node.
No, it's not just a leaf node either, because like times is a I don't know why I was just going on these ones, because like times and plus and this plus, those are tokens too. But like 3 plus x is not a token, 3x is not a token. It's just one. It's like the atomic indivisible, you know what I mean? It's something that's not divisible. Can't break it down into smaller parts.
Yeah. And I guess that's why I said it's a leaf node because it's just like it's done. There's nothing else you can do to it. It's what it is. It's at the
Oh, yeah, in a sense. In a sense, it's a leaf node, but it's again not literally a leaf node in this tree. But I get what you mean.
So tokens are always a length of one, right?
No, it could be like the number 55.
yeah, that's
Oh,
where yeah.
Um, yeah, okay. So let me see where I even was with everything. Yeah, so this doesn't make sense because it could be like 2x, and 2x is not a token.
So
So
should you bring up that constant method? Should that be up a higher level? Like maybe it doesn't belong in token? Or the same method needs to live in two places? That
yeah,
constant function?
I think maybe token is just it's not pulling its weight as a concept. We can put this stuff here. Okay. And so we can say, actually, sorry, I'm getting ahead of myself. I'm doing too much at once. So I'm going to just copy constant for the moment. Okay. And then I'll say if,
Just make it an argument value? Yeah.
yeah, if constant, whoops, I don't know why I typed constants, constant value. Okay,
That's
that works.
that's better.
Yeah.
Because it's not a token yet, so or you don't know if it's a token yet.
Yeah. Um, yeah, and if it is a constant, then it can be a token. That's plenty logical. Okay. Yeah, that addresses that. This clean thing I'm not super happy with. I'm gonna move that.
The clean it always felt like since you were always doing dot new then dot clean, I felt like maybe that you could put that into the initializer. I don't know. It's just something I kept noticing. You always had a dot new and then dot clean right afterwards.
Yeah,
Perhaps. Yeah.
clean does need to know if it's a constant. So I'm gonna put that here. Um, oh yeah, yeah. Okay, constant value. Okay. Okay, so here we do that. And here, whoops, we do that.
Where
But
else is dot
any
clean?
reason? Is there any reason not to just clean the value from the beginning?
Okay. Let's see, does that pass?
I have a hunch that okay, yeah, I was
Oh,
gonna
the
say I had a
strip.
hunch that that would fail. Let's see why.
Is they're all strip reasons?
Let's
Oh,
see.
cast.
Or if it's just 5, then we're saying if it's a constant. See what's going on.
Is it because you clean it before you test for constant?
Oh, I see what is going wrong here. I'm using the wrong value. I'm using value, not value.
Uncleaned, yeah.
Yeah, but why am I allowing such an easy mistake to be made? Like maybe I should just do that instead. Because it's all the same method. It doesn't have to be an instance variable. But then split on needs it. But that's the one and only thing that uses it. So I can just go like that.
Okay.
It feels a little bit lame to have to do that, but I prefer that over this really easy mistake. And maybe these should be separate methods anyway. When you
Oh,
find method strip for integer, okay. Well, we can do value dot. Wait. Feels a little funny to. I feel
yeah.
like this casting and the casting and the cleaning are like two different things.
Yeah, because clean is doing type conversion.
Yeah, it feels inappropriate. Okay, let's rename it to cast and take away the strip.
Because you did the strip up front anyways, right?
I'll change this.
But that uh hmm.
Okay. Okay, expected an integer of 5, but got a string of 5. So if it's a constant, then we can do cast value. Okay. And actually, if it's a constant, we already know it's an integer. So we can just do that. Okay. Oh, wow. Okay. So we
Okay,
don't even need cast.
I want to see that diff now.
Yeah.
Oh, okay.
Oh, we have the pry that I don't want.
Okay, how did that pry get in there without a test catching it? Oh, it's your okay, got it.
Yeah.
I thought it was a binding that pry that got in there.
Oh, I see.
So is this better?
I think so. It's at least not worse.
Yeah, it's better.
Okay, and now is there really any value to this?
Yeah, it's good. It's telling us stuff. It's the code's telling us things. So
Yeah.
you could probably just get rid of all the token.new and the code should work. If you just remove every token.new, and I think the code will pass, right?
No,
Oh,
because
there's token.value, right?
yeah.
Wrapper. Okay. It's a wrapper that doesn't actually wrap anything, or it doesn't decorate anything.
Right. Except I think it'll be useful. Well, something will be useful when we start doing the nesting, because we're still not doing the nesting yet.
Okay.
Or are we? Let's see. It has a left child with a left child of 2. Okay, left child dot root dot left child dot value we expect to be 2. Yeah, okay. So this doesn't work because this expression's left child's root is a token. Okay, so its left child is the times operator. So here we're saying the token. The root is a token with a times operator. Left child and right child are split on. Huh, I actually don't understand why that doesn't work. Okay, so this value is 2x plus 5. This value is 2x. This value is 2. This value is x. This value is 5. Okay. Nothing really looked surprising there. All right, so 2x plus 5. Maybe we want to be actually here. Okay, so it's splitting on 2x plus 5. And so it's going to give us 2 expressions, one for 2x and one for 5. Okay. And so when expression.new gets called with 2x, then we end up here. I have confused myself. Okay. So this expression's, let's do this actually. Expression. Oh, wow, we can see the whole thing here.
That's pretty cool.
Yeah. All right, I'm actually going to do this slightly differently. There. Okay. It's not the easiest thing to read. I'm going to start at the leaf nodes. Oh, wait. Okay, so the topmost expression has a value of plus. Its root is a token with a value of plus. Has a left child with a value of times. And by the way, it should match this. Should match this.
That's where a nice little debugging function, like a visualization of that tree, could be useful
Yeah.
later.
Okay. So left child of times, we're good so far. And then times itself should have a left child of 2. Okay. times has a root of times a left child. Okay, I'm getting confused here. This is hard to read. But we can do this. Expression dot left child. Okay. Expression dot left child dot root dot value times. Okay. What if we do left child dot left child dot value? Oh yeah. We don't want the left child's roots child. We want the left child's child. That makes sense. Okay, so the reason I was confused is because I wrote my test to assert the wrong thing.
Left child dot left child.
Yeah. Now, is the left child's right child X? What's wrong? Assertion.
Right child.
Yeah, you didn't change. There you go.
Okay. Wow, I can't believe that works. Okay. Well,
That
wow.
was a good test, yeah. Just need to test.
Yeah. Okay, well, now that we know that works, yeah, this token thing, it's like every node has a root token, left child token, and right child token. Hmm. Wait a second. Let's do this again. Okay, expression dot left child dot value. Okay, it's times. Okay, this is wrong.
Should be left child dot root dot value or left child dot value.
Okay, let me illustrate why it's wrong. Okay, is the times operator an expression? Conceptually.
Not by itself.
No, it's not. But look. So the tests all pass, but the program is conceptually corrupt because it's calling the times operator an expression, even though that's not true. It's not an expression.
So what is it supposed to be?
A token.
Oh, a token? Okay.
Mhm.
How about we add that test?
Good idea.
That makes me want to add assertions in a bunch of other places too.
Oh, yeah. What? Oh, left child dot
Root.
root. Never mind.
Yeah.
Yeah, okay. Expected token got expression. Oh wow, and we're already roughly at the hour mark.
And what's up with the encoding? That's weird.
That
Okay.
is kind of weird. I do not know what's up with that. Okay, I think I might wrap up in just a second here.
That's a good test. So when you come back to it, it's like that's where I left off.
Yeah. Yeah. Often people are like, wait, I don't want to quit. Let me get to a good stopping point. But a good stopping point is not a good stopping point. A good stopping point is like right in the middle of something.
That's a clear enough test that it'll remind you. Yeah. When you come back.
Yeah. Just because I can't help myself, I wonder what will be next. So when it's the left child, yeah, this should maybe be more agnostic because you can't be sure that both your children will be an expression. Your child might be a token.
Yeah. That's another test that's missing.
And I feel like expression and token should get collapsed into an even more generic concept.
But then are you gonna have to have like an expression dot are you a token method or something? Or
Well, what if we just circumvent the problem? What if everything is just a node?
okay. More generic, yeah,
Yeah.
perhaps.
Would an expression be a token? I'm sorry, an expression would be a integer and a string always.
Um, depends on exactly what you mean.
Like
Because
2x would be an integer and a string when it gets parsed. But 2 is always an integer or x is always a string.
and I think that brings up the fact that we're right now not making a super clear distinction between a string representation of an expression and an expression object.
Glad I could help.
Yeah. Yeah, so maybe that's an even that adds to the weight of the argument to actually kill the expression class and have a node class instead. Yeah. All right. Well, anyway, we'll save that all for next time. Okay. Thanks everybody for joining me, and I'll see you next time.
Have a good one. See you.